In this video, you will learn about right triangle trigonometry. So to begin our conversation, we want to talk about the different trigonometric functions. And you've probably learned some of these before in geometry class, where we have sine, cosine, and tangent. But we also have more than just those three. So we'll talk about those three in case you're not aware of them, but then also we'll expand our understanding to include three other trig functions. All right, so first off, these trig functions work only with right triangles. So we have a right triangle here, and notice we have an angle right here. By the way, the angle symbol that we typically use is the Greek symbol of theta. So it looks kind of like 0 with a line through it, kind of like an Easter egg maybe, and is spelled as theta, like this. All right, so if you're dealing with this angle right here, the side across from that is going to be the opposite side, and then the side across from the right angle will always be called the hypotenuse, and then the remaining side, the other side that is next to the angle but not the hypotenuse, is called the adjacent side. And with this information, with these different sides, we have different trig functions that are ratios of these different side lengths. So the first one is sine, and the abbreviation is sin. The full word has an e at the end, so sine is the full word. And sine is the opposite over hypotenuse side. Okay, it's the ratio of those two sides. The next one is called the cosine. Cosine is the ratio of the adjacent over the hypotenuse. And the full spelling of cosine is C-O-S-I-N-E, but the abbreviation is just C-O-S. All right, and then we also have the tangent. So the tangent of that angle is the opposite over adjacent. It is the ratio of the lengths of those two sides. And the full spelling of the word tangent is T-A-N-G-E-N-T, but the abbreviation is T-A-N. So these are the three main trig functions that you may have learned before. And if you want a way to remember this, okay, remember what ratios are which, okay, sine starts with an S, and that has O and H, opposite and hypotenuse, so S-O-H. Cosine has adjacent and hypotenuse, so C-A-H. Tangent has the opposite and adjacent sides, so T-O-A. You put that together to make this weird sounding word or sentence, and it's SOHCAHTOA. All right, and if you want another way to remember which letters are what and what ratios are which, you could assign a word to each of these letters to help you remember. And the one I have is really weird. You're welcome to make your own, but the one that one of my students shared with me in the past was some old hippie caught another hippie tripping on acid. All right, so that may be helpful for you, may not, but either way, make sure you have these ratios memorized. Now, the other three trig functions are the inverses of these. So the inverse of sine is going to be called cosecant. So that's spelled C-O-S-E-C-A-N-T, cosecant. The abbreviation is CSC. And notice the ratio for cosecant is the inverse of sine. Instead of opposite over hypotenuse, it is hypotenuse over opposite. And then we have the inverse of cosine, which is secant, so S-E-C-A-N-T. The abbreviation for that would be S-E-C. And again, we just switch the numerator and denominator of cosine. So instead of adjacent over hypotenuse, we have hypotenuse over adjacent. And then the inverse of tangent is called the cotangent. So cotangent is the inverse of tangent. We abbreviate that as COT, and we basically just switch the numerator and denominator. So instead of opposite over adjacent, we now have adjacent over opposite. So make sure you have these memorized as well. So if you have these memorized over here, okay, if you have those memorized, and then just realize these are the inverses, it's going to help you to remember what these ones are in this column on this side. And tangent pairs up with cotangent. That's kind of easy to remember. Personally, the way I remember which ones pair up with sine and cosine is it's like the opposites. So like the sine, you would think would pair up with something that starts with S maybe, but it doesn't. It pairs with the C, and the C cosine pairs with the S. So it's kind of like flip-flop as far as the letters, the alliteration. But again, you can choose whatever way you want to remember these as long as you have those memorized. So assuming we have those memorized, assuming we know what these are, we can now expand on this and learn how to evaluate trig functions. So let's take the same triangle right here. So we have the same theta, but now we have the adjacent and opposite sides given to us. So again, this would be opposite, and then over here the 8 would be the adjacent side. And if we try to find all these different trig functions, we need to find hypotenuse. So we can find the missing side by using the Pythagorean theorem. So the Pythagorean theorem says that c squared equals a squared plus b squared. So we're assuming you have a background with using this formula, but to remind you of what to do, the adjacent and opposite sides, so the two legs of the triangle, that is your a and b value. So you have 8 squared and 6 squared for a and b, and the hypotenuse will always be your c value. So just plug everything into the formula and then solve for the unknown side. So here we have c squared equals 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36, that gives you 100. C squared is 100, which means c would be the square root of 100, which is 10. So the hypotenuse is going to be 10. And then from here, we can find any trig function that we want. So if this is your angle, if that's the angle we're referring to, the sine of that, sine of theta, would be opposite over hypotenuse, which would be 6 over 10, which reduces to give you 3 over 5. Cosine of theta is adjacent over hypotenuse. That'd be 8 over 10, which would be 4 over 5. And then tangent of theta is going to be opposite over adjacent, which is 6 over 8, which reduces to get 3 over 4. And then we can do the inverses of each of these. So the inverse of sine is cosecant. So the cosecant of theta, instead of 3 over 5, we now would have 5 over 3. The cosine of theta, do the inverse of that, that'd be secant. So secant of theta, and instead of 4 over 5, we now have 5 over 4. And then the inverse of tangent is cotangent. So the cotangent of theta, instead of opposite over adjacent, we have adjacent over opposite, which would be 4 over 3. So we can use this information to find any trig function that we want. Now let's use that information to increase the difficulty a little bit. And here we have a problem where we are told that if the sine of an angle is 2/3, find the tangent of that angle. So when you see a problem like this, where you're given the ratio, whether it be sine, cosine, tangent, or any of the other inverses, what you want to do is you want to create yourself a triangle. This is to help you think through what we have. So it doesn't matter how you create the right triangle, but you pick an angle, and we'll pick up here just because. So if this is your angle, okay, sine is opposite over hypotenuse, right? So we're assuming that we know those ratios, and it says the sine of this angle is 2 over 3. So that means the opposite is 2 and the hypotenuse is 3. So that means if we look at this angle right here, opposite is over here, that is 2. Hypotenuse across from the right angle is 3. So we now have this right triangle where we have the opposite and the hypotenuse, and then we can find this missing side length again by using the Pythagorean theorem, where we have c squared equals a squared plus b squared. C is given to us in this case. It is 3, the hypotenuse. And then a squared, we'll call that the adjacent side. And then plus b squared, that would be the 2 squared. So now we have 9 equals a squared plus 4. Subtract 4 to the left. That gives us 5 equals a squared. Take the square root So a would equal the square root of 5. So that would be this length right here, and that is the adjacent side. So once we have this, we can find any trig function that we want. So here, we just want the tangent of the angle, but we could find any trig ratio. So looking just at the tan of theta, tangent is opposite over adjacent. That would be 2 over the square root of 5. So that would be the tangent of this angle. And you can rationalize this as well, meaning get rid of the radical in the denominator, where you multiply top and bottom by the square root of 5. And that would give you 2 times the square root of 5 over 5. So you could write it either way, it doesn't really matter. But this would be the tangent of that angle. Now in trigonometry, we do a lot with the special triangles, the special right triangles, so the 45, 45, 90 triangle and the 30, 60, 90 triangle. So we're going to go through this, figure out the ratios, the sine, cosine, tangent of each of these, and also the inverses. And our goal at the end of all this is to show you a pattern with which you can memorize these. All right, so jumping into our 45, 45, 90 triangle, we have to think back to geometry when we learned that with these types of triangles, the legs are the same length, and the hypotenuse you multiply by the square root of 2. So, for example, if this is 1, okay, the other leg would also be 1, and the hypotenuse would be 1 times the square root of 2. That is the relationship. So with that being said, we can, from this, derive our different trig functions. So sine of a 45-degree angle, it doesn't matter which angle we pick because they're both 45. Let's say we pick this one right here. This would be opposite. This would be adjacent. And then this over here is your hypotenuse because it is across from the right angle. So if we did sine of 45 degrees, that is opposite over hypotenuse. So we have 1 over the square root of 2, which you can also write as the square root of 2 over 2. You can rationalize that. All right, and then cosine is adjacent over hypotenuse, which would still be the square root of 2 over 2. It's the same numbers. Tangent of 45 is opposite over adjacent, which is 1 over 1, or just 1. Now once we have these, it's very easy to get the inverses of them. So the inverse of sine is going to be cosecant. So if we do the cosecant of that angle, you basically just switch the numerator and denominator. It's going to be the square root of 2 over 1, which would just be the square root of 2. And then the secant of 45, that is the inverse of cosine. So if we do the inverse of cosine, we get the same thing as the inverse of sine, which again would be the square root of 2. And then the cotangent, that is the inverse of tangent. So here the inverse of 1, or 1 over 1, would still be 1. So the cotangent of 45 degrees would also equal 1. All right, so these are the different trig functions for the 45, 45, 90 triangle. And don't worry about memorizing them quite yet, because we're going to give you a way to remember them more simply in a moment. Before we do that, we want to talk about the 30, 60, 90 triangle. So here we have a 30-degree angle, 60-degree angle, and a 90-degree angle. And there is a relationship between the different side lengths. So here, if we start across from the 30-degree angle, whatever this is, the hypotenuse would be 2 times that length. And then this other side over here is multiplied by the square root of 3. So if this opposite side has a length of 1, that means the hypotenuse would have a length of 2, 1 times 2. And then the adjacent side would be 1 times square root of 3, or just the square root of 3. So that is the relationship between the different side lengths of a 30, 60, 90 triangle. Now with this information, we can very quickly get our sine, cosine, and tangent, as well as the inverses, where sine of the 30-degree angle, the 1 is the opposite side, square root of 3 is adjacent, and then 2 is your hypotenuse. All right, so the sine of 30 would be opposite over hypotenuse, or 1 over 2. Cosine would be adjacent over hypotenuse, which would be the square root of 3 over 2. tangent of a 30-degree angle is opposite over adjacent, which is 1 over the square root of 3, which can be rationalized by multiplying top and bottom by the square root of 3, and that would give you the square root of 3 over 3. And then if we do cosecant, secant, and cotangent, we just do the inverses of each of those. So cosecant would be 2 over 1, secant would be 2 over the square root of 3, which can rationalize, multiply top and bottom by the square root of 3, and that gives you 2 square root of 3 over 3. And then cotangent is the inverse of tangent, which would be the square root of 3 over 1, or just the square root of 3. So that is with the 30-degree angles. You could also do it with the 60-degree angle. So if you look at the 60-degree angle, the square root of 3 is going to be the opposite side, and then the 1 would be the adjacent side, and the 2 is still your hypotenuse. So we can go through everything again with 60 degrees. Sine is opposite over hypotenuse, so the square root of 3 over 2. Cosine is adjacent over hypotenuse, which is 1 over 2. Tangent is opposite over adjacent, which is the square root of 3 over 1, or just the square root of 3. And then we can find the inverses of each of those. So the inverse of sine is cosecant, which would be 2 over the square root of 3, which can rationalize to get 2 square root of 3 over 3. And then the inverse of cosine is secant, which would give you 2 over 1, or just 2. And the inverse of tangent is cotangent, which would be 1 over the square root of 3, which can rationalize to get the square root of 3 over 3. So it's a lot of work we just did here, and we could go through this thought process to derive any of these very commonly used trig functions, but it's going to be helpful if we can memorize them as best as possible so that we can use them at any moment. So what we have here is a memorizing tip. All right, so here if you look at the sines of each of these angles, 30 degrees, 45 degrees, and 60 degrees, notice the pattern. Okay, we have the square root of 1 over 2, the square root of 2 over 2, and the square root of 3 over 2. So the pattern is here inside the radical. We have 1, and then 2, and then 3. And that's the pattern. So with sine, we start with a smaller number. We start with 1, and then go to 2, and then 3. And then with cosine is the inverse of that. So instead of starting with 1, we start with 3, and then cosine of 45 is the square root of 2 over 2. And then the cosine of 60 degrees is going to be 1, the square root of 1 over 2. All right, so notice the pattern. And if you're forgetting which one is increasing, which one decreases, one way you can remember is sine starts with an S. We start with the smaller number. So smaller starts with S as well. So we start with the 1, and then 2, and then 3. Whereas cosine is not the smaller number. We start with the bigger number, start with the 3, and then decrease to get 2, and then 1. So that's a quick way to memorize the sine and cosine. And then if you want to get tangent, a quick way to get tangent is if you know that tangent is equal to sine over cosine, which we're going to talk about more in the future as well, but if you know this at this point, it's going to help you get the tangent, because if we just do sine divided by cosine, we get the tangent function. So for example, if you're looking at 30 degrees, and you're trying to find the tangent of 30 degrees, okay, what that means is we take the sine of 30, which is square root of 1 over 2, or just 1 over 2, and then divide by the cosine of 30, which is the square root of 3 over 2. All right, so when you divide, that's the same thing as multiplying by the reciprocal, which would be 2 over the square root of 3, and then the 2's cancel out. You're left with 1 over the square root of 3. Then you can rationalize that as well if you want. Same thing with the 45 and the 60 degrees. Just divide. So we'll do one more, tan of 45. If you divide sine of 45 and the cosine of 45, notice you're actually dividing the same thing, right? Square root of 2 over 2, divide by square root of 2 over 2. When you divide anything by itself, it will always equal 1. So the tangent of 45 degrees is equal to 1. And then we can do the same thing for sine or the tangent of 60 degrees. You can do that on your own if you want. And you should be getting the square root of 3 if you do that correctly. So again, if you have these memorized, you can get all the tangent functions, and then you can also get all the inverse functions. All right, because realize that cosecant is the inverse of sine, so you can think of that as 1 over sine. All right, and then secant is the inverse of cosine, so that's 1 over cosine. And then cotangent is the inverse of tangent, or 1 over tangent. So you could think of it like this, or just simply switch the numerator and denominator of sine, cosine, and tangent to get cosecant, secant, and cotangent. So again, it's going to be helpful to have these memorized because, for example, you might have something like this where you're told to evaluate a trig expression. So here we're trying to find the exact value of the sine of 45 degrees plus cosine squared of 30 degrees. And there should be a degree symbol right here. So assuming we have these memorized, okay, we can just basically plug in numbers. Now it's worth noting though, before we do this, that this notation right here, cosine squared of 30 degrees, that is our way of writing cosine of 30 degrees, so this value, whatever that is, squared. So it means the same thing, but we write it this way when dealing with sine, cosine, or tangent. So again, assuming we have those ratios memorized, the sine of 45 degrees would be the square root of 2 over 2, and then the cosine of 30 degrees would be the square root of 3 over 2. And then we have to square that, square root of 3 over 2, because we have that cosine squared right here. So now we just go through the arithmetic of figuring out what this would equal. So if you do the square root of 3 over 2 squared, what we have would be the square root of 3 squared, which would be 3, and then 2 squared, which is 4. So what we have now is the square root of 2 over 2 plus 3 over 4, and then we can combine this into one radical, or into one fraction. So the square root of 2 over 2 we can write as something over 4, so that way we can add it with 3 over 4. So to do that, we multiply bottom by 2, and then the top by 2 as well. That gives you 2 times the square root of 2 over 4 plus 3 over 4. Put that together into one fraction, and that gives you 2 times the square root of 2 plus 3 over 4. So this would be the exact value of sine of 45 degrees plus the cosine squared of 30 degrees. So a lot of those common trig ratios you can have memorized and just pull from your memory, but most of them you're going to need to use a calculator. And that's what we're going to do now at this point, is show you how to use a calculator. And what we have here is Google Calculator. So if you just go online, type in calculator into the Google search bar, this will pop up. So you can use this, or you can use an actual calculator or a calculator app. Whatever it is fine. But here we're going to show you on Google Calculator what you should do. All right, so we have 5 different problems on the right side of the screen. And here we see first one is sine of 50 degrees. So notice on the calculator we have sine, cosine, and tangent. Also realize up here we have radian and we have degree. Make sure the correct one is selected when you are doing your calculations, otherwise you're going to get the wrong answer. So we're in degree, click degree. We're trying to do sine of 50 degrees. So you go in here, press sine, then type in 50, and then press enter, and that gives you your answer, which we'll type in here as well. So the answer is 0.766. All right, so that's the first one. And then we have tangent of 115 degrees and 40 minutes. Realize that minutes is 1/60th of a degree. So 40 minutes would be 40 over 60. 40 divided by 60. So that would be 0.66 degrees. And then you add that with 115. So that would be 115.6 repeating degrees. And then we want the tangent of that number, the tangent of that degree measure. So we press tangent, and then you can press this ANS button. This means tangent of the previous answer, ANS for answer, and then press equal. That gives you your solution. So this would be negative 2.08, we'll round 0.2 or 2.081. All right, so that would be how to do a calculator with minutes. And then here we have secant of 70 degrees. So realize that secant is the inverse of cosine. So what we can do is we can find the cosine of 70 degrees, so cosine of 70, and then do the inverse of that. Now be careful, you don't push the inverse button, that's a different thing. What you're doing when we say find the inverse is we do 1 divide by that number. And that would give you a solution of 2.924 when you round it. So that would be your answer for secant of 70 degrees. Now over here on the right side, we have cosine of pi over 8. Notice there is no degree symbol for this one or the next one, which means we're not dealing with degrees, we're dealing with radians. So then make sure you select the radian mode on your calculator, and then just type in what we have. So cosine of pi divide by 8, and that gives you a solution of 0.9238. So we'll round that actually to 0.924. All right, so that's the cosine of pi over 8. And then the last one we'll do here is the cotangent of 3 pi over 5. Now, there is no cotangent button. And by the way, it's worth noting as well that if you press inverse on the calculator, okay, it says tan inverse. That is not the same thing as cotangent. Okay, tan inverse, or the inverse functions that we see here, that is used later to find an angle measure when you are given the ratio. All right, so it's not the same thing. So, but we do know that cotangent is the inverse of tangent. So what we can do is find the tangent of the 3 pi over 5. So 3 pi divided by 5. And that gives you this number. But then cotangent is the inverse of that, meaning that we do 1 divide by that answer. And that would give you a solution of negative 0.325. All right, so that is how you use a calculator. We've dealt with pretty much every type of calculator problem you'll see with sine, cosine, tangent, and also the inverses of those functions. Now that we know how to use our calculator and also how to understand the different trig functions, what we're going to do now is give you an application of the trigonometric ratios. And here our example that we're going to look at is angle of elevation and angle of depression. So what this is let's say we have a person. So here is a person looking across horizontally. And let's say he's looking up into the sky and there's some object up here. So there's some object, and the angle right here, the angle between the horizontal line of sight and going up to the object, that is called the angle of elevation. And that one is a little more intuitive than the angle of depression, because the angle of depression is this angle right here. So if he's looking down at an object, so say he's in the sky or something like that, looking down, the angle of depression would be this angle right here, that is between the horizontal line of sight and down looking towards the object. So make sure you know the angle of elevation and angle of depression and how to interpret that into a picture if needed. Because here we're going to look at an application where Brian's kite is flying in a field at the end of a 65-meter long string. If the angle of elevation of the kite is 70 degrees, how high is the kite above Brian's head? So when you do this, it's helpful to draw yourself a picture. So down here, this is the ground. All right, and then the kite is somewhere up here in the sky. That would be his kite. And let's say you're down here, and the string for the kite is going, let's say it's from the ground. I guess technically you'd be holding it, but for the example, we'll just say it's from the ground, and that's going up here to the kite. So the length of the string from the ground to the kite is 65 meters, so we know that length. We know that the kite is going to be perpendicular to the ground. It's going to be 90 degrees. And then we know the angle of elevation is 70 degrees, which is this angle right in here between the horizontal line of sight and going up to the object. So that is 70 degrees. And what we're trying to find is the height. How high is the kite above Brian's head? And that would be this unknown side right here. So this is our picture that we can use to then solve. So to solve for the unknown, and you're looking at the 70-degree angle, the unknown side is opposite from the 70-degree angle, and then the 65-meter length is the hypotenuse. So when you're trying to solve for an unknown side length, you have to figure out which trig function uses the sides that we have. So we have opposite and hypotenuse. So which trig function uses opposite and hypotenuse? Well, that's going to be sine. So what we do is we do sine of 70 degrees, sine of that angle, is equal to opposite, which is x, over hypotenuse, which is 65 meters. And we see all that typed up right over here. So now what we can do, and we chose h instead of x, but same thing, what we can do from here is we can then solve this for the unknown side length. So get h, or the variable, by itself, multiply both sides by 65. So now we have 65 times the sine of 70 degrees equals h. So now you just type this into your calculator. Make sure that you have your calculator in degree mode. So you do sine of 70 degrees. That gives you 0.9397. Multiply by 65. That gives you a height of 61.0805. So the kite, we would say, is about 61 meters above Brian's head. That is our solution. Now let's try an example looking at angle of depression. So here our example says that from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? So again, it's helpful to draw a picture when you have these word problems like this. So right here, we'll say this is the cliff. So this is 40 meters in length. That's the cliff, 40 meters. So that's the cliff. And then the base of the cliff would be down here. This would be the ground. And it says there's an object down here that is level with the base of the cliff, and it says the angle of depression is 34 degrees. So if you're up here on the top of the cliff and you're looking down, okay, it says the angle of depression is 34 degrees. Now be careful, because the initial thought is that this angle is 34 degrees, but it's actually not. It's not that angle, because the horizontal line of sight is right here, and the angle of depression is the angle in between that horizontal line of sight and the object, which would be right in here. So this angle inside of this is 34 degrees. So from this point, we can actually figure out both of these angles very quickly. This is 90 degrees. And if you remember with parallel lines, that if you have parallel lines, the alternate interior angles would be congruent. So if this is 34 degrees, then down here would also be 34 degrees. If you do not know that, you could still figure out this angle up here on the top, because if we combine these two angles together, that equals 90. So if we subtract 34 from 90, that would give you, what, 56 degrees? So this angle is 56 degrees right here. And then if you wanted to, you can find this angle from that information, because 56 plus 90 plus 34 would have to equal 180. So again, for that reason, we can calculate this angle to be 34 degrees. And one more way we can look at this picture is we could have actually drawn this right here. So if you know that this angle is 34 degrees, you can draw a replica, a reflection of this triangle that was down here, and get the same picture. So this would be 40 meters. And then this angle is 34 degrees, and this is 90 degrees. So either way, it doesn't matter how you think through this. There's like 2 or 3 different ways you could get this set up. But our goal is to have this picture that we can work with. And here we see the picture drawn instead of done by hand. So we're going to take a look here, and what we're trying to find is how far is the object from the base of the cliff. So if your object is down here, the distance is going to be this side length down here at the bottom. So the length from here to here is what we're trying to find. Alright, so if we're using this 56-degree angle within the triangle, the x would be opposite of that, and then the 40 would be adjacent. So with that information, we can then figure out which trig function uses opposite and adjacent, and that would be tangent. So what we can do is take the tangent of 56 degrees, and that's equal to opposite, which is x, over adjacent, which is 40. And then from here, we can solve. So multiply both sides by 40. That would get you 40 times tan of 56. And then just type this into your calculator. So make sure you're in degree mode and do tangent of 56 degrees. That gives you some number. Then multiply that by 40, and your solution is going to be 59.3024, which rounds to about 59 meters. So this length is going to be 59 meters. We'll take a look at one more application problem, and this one is actually something that I personally have used in my everyday life, and I'll lay out the scenario of what we use it for. Alright, so back when I was visiting my family, back a couple summers ago, we were trying to cut down a tree, and this tree was kind of close to the house. We weren't sure if when we cut it, if it fell in the wrong direction, if it would maybe hit the house or not. So what we wanted to do is figure out how tall is this tree, and then figure out if it did go in the wrong direction, would we risk the chance of hitting the house? So with technology now, there's apps for everything, it seems like. And there's a simple app you can get on your phone where you can find the angle of inclination, or same thing as angle of elevation. And what this app did is you just basically pointed it up into the sky, like wherever you're trying to look at. And in this case, we aimed the phone up to the top of the tree, and the phone gave you that angle of elevation. So here I was over here, okay, and then here's the ground, and then there's a tree, and don't judge my drawing skills. So something like this. Okay, and we used the phone app, and we aimed it up here so that it was to the top of the tree. And the phone gave you this angle. So it gave you this angle of elevation. So let's say, for example, it was 45 degrees, which is actually what I think it was. It was about 45 degrees. And we're trying to find this height over here. And we could measure the distance from the tree to where we were standing. So let's say, for example, it was 50 feet. 50 feet, and we're trying to figure out the height of the tree. We can very quickly use our trig ratios to find the height of the tree. So here in this example, okay, we have opposite, and then we have adjacent. So tangent is the function that uses opposite and adjacent. So what we did was we took the tangent of 45 degrees. That's equal to opposite, the x, over adjacent, which is 50 feet. And then from here, we just solve this for x. And this was actually a pretty simple one to solve, because the tangent of 45 degrees is 1. So you have 1 equals x over 50. Multiply both sides by 50. That gave us x equaling 50 feet. Alright, so our answer in this example is the tree was 50 feet tall. And from this real-life example, our conclusion was that the tree would not hit the house, and so we were not fearful when we were cutting down the tree. So again, there's applications for this. This is just one example. and we already looked at a couple other examples as well. And this concludes our lesson for today. We will see you next time.